Okay, year 7. Hope the formative exam went okay for you. Just a few things that you may be confused about. And the first one could be plotting points. So if we get a point, it'll have an x and a y coordinate. So for instance, 2, 3. So 2 and 3, that'll be the x and that'll be the y coordinate. This is the x-axis. This is the y-axis. So it always x first, y second. So we go to the x-axis first, we find 2. Here's 2. And then we start there and go on the y-axis up or down. So in this case, it's up to 3. So you keep it there, put a dot, put the point 2, 3. Always mark your point. Okay? So that is plotting points on a Cartesian plane. That's what this thing is called. Another issue with some transformation questions. We have a triangle such as this, and we are given a vector. And we're told to translate using a vector. So this is the vector translation, 2 minus 1. So this number on top refers to left or right. So the thing is going to move left or right, like move it over left or right, this much. So this one's going to move to the right 2 units, and minus 1, well, that's telling us up or down. In this case, it's going to be down. So this needs to move right 2, down 1. So the shape will move 2 boxes to the right and down 1, each of these points. And so it would end up here. You can test this one is moved 2 and down 1. Okay? So that is when we're doing translations in vector form. So they might just give you that vector, and you need to know that the top bit is left and right, and the bottom bit is up and down. Some other issues that may have come up in the formative exam. Rotational symmetry, if you remember rotational symmetry. So it's when you spin something around and it looks exactly the same in different positions. So for instance, if we are spinning around a rectangle, it will spin around and look the same twice. So you start spinning it around, when it's on its side, it doesn't look the same. It looks different, so that's not. But when it is upside down on the spin, it does look the same. So that'll be 1. And then when it comes around, so that's at 180 degrees, it looks the same when it's upside down. And we spin again, 90 degrees, another quarter turn, 270, it doesn't look the same. But when it reaches 360 again, it does look the same. So you spin your shape, and every time it clicks into position, you count that as a rotational symmetry order. So this one has 2. So you count the finish position, not the start position. So that'd be a rectangle, it's 2. Some issues with a transversal, so that's this line that goes through 2 parallel lines. Some bits of theory that you need to know. 2 angles, if they're on the same side of that transversal, like here and here, these 2 are called co-interior, and they add up to 180 degrees. If one angle is on the other side of the line to form a Z shape, that is called alternate. Those angles must be the same. You see they're both acute here. They'll be exactly the same degrees if these are parallel lines. If you have an angle in the same position, so you can see that this angle here is in the same position as this angle here in its parallel lines. So the 2 parallel lines have 4 angles here in a set, 1, 2, 3, 4, 1, 2, 3, 4. So if it's in the same position, it's called corresponding, and they will be exactly the same degree. So you need to know those words. If they're vertically opposite, so this one and this one are vertically opposite, so they form an X, that will be also the same. So if you form an X, you can see as my hands get closer together, my elbows get closer together, my hands get further apart, my elbows get further apart. That always happens when two straight lines meet, so they are the same. So that's some theory. Triangles, remember the three angles of a triangle will add to 180 degrees. If it's a four-sided shape, it will include two triangles. So we've got something like this. Looks like a trapezium, but if we split it up, it's got two triangles, 180 degrees, 180 degrees, both of them add together 360 degrees. We looked briefly at an exterior angle, which came up in the practice test. This angle must equal these two added together. The reason why is because these two are a straight line, they add to 180, so what's left over must be the same as what's here. Okay, or you can just remember exterior angle would equal the opposite two sides. But it's better to know the theory because these two add up to 180. But this also adds with these two to 180, so these would equal. Okay. Some other things that may have come up in the practice exam. If you're doing a rotation, so you have a shape and you need to rotate it, you need a center of symmetry, and it'll be given to you in the question. Usually we use 0, 0, which is here, but we don't have to. We could have used 1, 1 here, for example, as our center. And then you need to get a piece of paper, maybe tracing paper if you have it. If not, just any paper you can see through. So you place it, you would trace your shape, you can do it pretty roughly, and then you know that this way is the way the clock goes, so that's clockwise. This way is anti-clockwise, so that's 90 degrees, 180 degrees. I see the way on my pen at the point of rotation, and then you can draw in your triangle when you hit the right spot. So you can allow tracing paper or white paper in the exam. I will have tracing paper for you if we're able to do it here. The exam on Friday will be online, so it'll just be theory. I won't be asking you to draw anything. It'll be just theoretical, and maybe it'll be a question like this. What is the center of rotation? So you could name that. Or what are these two angles called? They'd be called corresponding. How many degrees in a triangle? So theory like that. I won't be asking you to draw anything online. If there's any further questions you'd like me to go through in the forms of the exam, please let me know. And that's it for today's video.